Hi guys, back to day 3 of Arduino Workshop. Right? So just let me know if everything is like my screen is visible or not, and are you able to hear me or not? All those things just cross verify. Let's cross verify it. Then we will start the session today. Okay? And we will wait for a few minutes. Like we will wait for 15 minutes now because class starts at 7 o'clock. Let's check how does it goes. And if you don't have link, let me provide you the link of day 3. Okay, day 3 link. And everybody whoever send me that send me your code, each and everything. It was really great. I loved it. You guys are like just nice. I appreciate your efforts. So in today's class, basically we will be learning to optimize the code more better way, and then we will be learning with inputs. Today, like yesterday's class, we learned about outputs, how to do outputs, and today's class we will be learning about inputs. Okay, so okay, still nobody came, or people are coming. Let me know, guys. Am I visible? Oh, let me have a net check once, like how fast is my net. Oh, it's 930 Mbps per second. Decent amount of speed, right? Yeah, 930. Upload and download both. Great. Okay. Let me know, guys. Can you see me? And today we have to learn many new things. And today's part will be mostly towards CS part because yesterday we learned about electronics and you learned which LD like which registers to use and how you learned array of LED and you learned some patterns, which was really great. I appreciate that. But in today's class we'll be learning how to make that little bit more easier, by which you need to struggle a lot to write the same code multiple times, right? I'll just copy the code of any one of your friends, and I will show you, okay, what you guys have done. mm, Somebody is messaging me, is that it's free or paid? Of course it's free. mm, okay, let me know, guys. Like comment me, guys, then I'll get to know that are you energetic to learn today something new and how to optimize your code. It's already 6:50. Nobody came. Something strange is happening. Why today is so less people? Was my daily content which I delivered was not up to the mark or something like that? I hello bro. Hmm. There are 9 members. Okay. No issues. Hi Bhuvan. 'Okay, I will keep everything ready. Pin number 13. One, two, three, 4. Hi Manoj. We are more 8 minutes away to start the class. Let me show you what I am doing exactly. You will not feel bored till that time. Open. I will request you to open the Tinkercad. Whoever already have joined, just I will request to open the Tinkercad and be ready. Mm, yep. So we will just connect, keep on connecting wires. We are not that much aesthetic, but yeah, okay. So any doubt from yesterday's class, guys? Let me know. Yeah, you can do it in breadboard. That is not bread sheet. That is not a breadboard actually. Breadboard is a like tool where you can like for prototyping stage you can just connect it in the top of it and you can start running with it. So when you will be having physical class, then you will be able to understand the breadboard. How does it look and how can you use it? Okay. Um, Basically we use it for prototyping stage when we don't want to like make anything permanent. That time we go with breadboard. Say this was what which was done yesterday in like many of you have done in yesterday's class, right? Not many of you, everybody has done the same thing only. Whoever has sent me the code, like yeah. But today it's not like you have done it wrong, it's correct only, everything is correct. The thing is like you can make it more optimized by which you can reduce little bit of space. You can optimize memory, you can optimize the code readability, like the amount of code. Example, if you see this code, it's of 39 lines, right? I can reduce it and I can bring it under 20 lines of code. How that all things we will be learning today. Okay, so we'll wait for more 3 minutes and then we'll start. Okay, yeah, we'll wait for. Hmm. Okay. Okay. So should we start the class or should we wait for more like for for few more minutes? Yeah. Hmm. So it's already 7 o'clock. So so yeah, let's start the class for today's. Let me check once again like how many people are there already. Okay, 49. Okay, we will start. I guess people will keep on joining. I will request people like if you are joining now, just go a little bit back and let's Then we will start, like you can start listening. Okay. So in yesterday's class, I gave you a homework, right? I guess you guys remember, right? I told you to blink 5 LEDs, right? So many of you have sent me personally the message with this kind of codes, right? You have taken five LEDs, you have connected with resistors, and then you have connected with pins. And in yesterday's class, if I try to revise what we have learned in yesterday's class, we learned basic of programming, which is variables, where you are storing the number into a name. You are giving a name to it, right? That thing we learned here. So instead of calling 13 every time, I might not remember the 13 number every time. So a human can remember names very easily. So I will remember LED1, by which I will be like, okay, whenever I say LED1, it means that it's 13. So in this way, I have given five names: LED1, 2, 3, 4, 5, and then in void setup, we just always we tell microcontroller it's an input device or it's an output device, right? So in that we learn using pin mode function. Pin mode, M is capital, which is also known as camel casing. Using calling this function, we are declaring which pin to use, and it's an input or it's an output device, right? You have mentioned this five pins are output device, as we mentioned, right? Then void loop. In void loop, we learned about digital signals. As I guess you guys remember digital signals, right? Ones or zero, right? The same thing, ones and zero. LED1 high, LED1 low. Okay, we are writing it for pin number one. What is pin number one? Pin number is a 13 is a pin number one, right? 13 comma high. High means what? 1. Low means what? 0. Then delay will make it stop for few milliseconds. Now 500 milliseconds is equal to half second, right? 1 second is equal to 1000 milliseconds, that we learned yesterday. Then what it is doing, the moment it is turning on the LED1, like pin number 13, it is turning on, then stopping for 500 milliseconds, like half a second, then it is turning off that LED, then it is turning on the LED2, then half a second off, then again it is going like after half a second it is offing, right? If you see the simulation of this, see, you can see it's like in a particular pattern. It is going like 1 2 3 4 1 2 3 4 1 2 3 4 like that, right? This was the code which was given by every one of you, which is really great and I appreciate it. But you can do it in more easier way. What is that way? Using list. I hope you guys remember what is list and how to make the list. Here I have, to save the time, I have already written. Let me explain and teach you. Okay. So here you have made a list. Now how to create a list in an C language? Generally we say array. In Python language, we say it list. Okay. So whenever you want to make an array, now if I teach you the basics of C language, like how do you identify? Example, if you make an array, okay, you made an array of few variables. It can be A, comma B, comma C, like that. Okay. Now computer tries to remember it using index value. Index value is like identify the location of that number. Okay. Now example, here I have written ABC. Right. Now ABC, always A, the first value will always start with 0. 0, 1, 2, 3, 4, 5, 6. Like the length of that array will continue. Example. Now I will ask you one question. If I want to read number 4, right? If I want to read number 4, what what will be the index value of it? Can you just comment me? What will be the index value of number 4? As I told, see, if you want to access any of the number, you will be using index value. Now you will be saying like, sir, why we should make a list? Why? Because see, earlier in earlier code you have written five variables: LED1, LED2, LED3, LED4, LED5. But writing that multiple times will increase fatigueness, and you will like you are using unnecessary memory, like unnecessary power of while typing, right? So to save that in one line, you can do everything. So you have made an array of like you have made LEDs, then you can call it. Yes, correct. 2. Okay. Kiran, it's not 3, it's 2 actually. Why? Because see, as I told, it always starts with 0. So 0, 1, 2. So to access for number 4, I will be writing 2. Now, if you see this void setup code, Okay. If you see this white setup code, what I'm doing, for loop. For loop, I hope you guys know how to write, what is the difference between for loop and while loop. While loop will keep on looping and for loop is a sequential looping. Okay. So here what I told, I took a variable again. What is variable? To declare a name. Now in this name I, right, I have initialized as 0. So now what is my I value is 0. Now it says is the I is smaller than 5. What is the I value? I value is 0, right? So I value is 0 and 5 is greater. Is it true? Yeah, it's true. So it will run this code. Then after running the code, what it will do? It will do I plus plus. What is I plus plus? I plus plus means I plus 1. It is known as incremental. If you want to decrement it, it will be like I minus minus. Okay. So if you want to go one step ahead. Example, if I type LEDs 0, I am accessing 2. If I am writing LED 1, I am accessing 3. Like that. Getting my point? Like I plus plus is just incrementing one step. If the value was 0 now, it will become 1. Then again if I plus 1, 1 plus 1 2, 2 plus 1 3, 3 plus 1 4. And like that, it will keep on looping. And the moment it comes to, see, 0, like what is the index value of this? Just now we learned, right? 0, 1, 2, 3, 4. So the 4 is our max, right? Now if you see here also, is 5 is greater than 5. Both are same. They're not like they're not greater or smaller, right? It's false. That's why if you want to solve that kind of issue, you need to put is equal to here. Okay. But it will create an issue. Why? Because our number counting was started from 0 and it should go till 4. It should not touch the 5. So that's why we always go with I is smaller than 5. If 5 is same than 5, it is a false. So it got over. The moment this if condition, this I is greater than this logical, if condition is false, it will come out of that loop. Okay, getting my point? Now example, see here also, pin mode, same function we are using, but now this time we are using LEDs. Now why LEDs? It's a function. Now as I told, like I want to find the, if I want to get value of 4, you told, right, 2. The same thing. I will put I value here. What is I value now? I value is 0 now. So I value 0 should be output. What is 0 here? 2. 2 is output device. So now I have made that Arduino pin to make it 2, like to make it output device, right? Now again, it will take one more loop. After taking one more loop, now I is became 1. Now I is 1, 5. It is I like if is 1 is smaller than 5. Yeah, it's true. Then again, LED is 1 is should be output. What is LED 1? It's 3. Value is 3, right? So in this way, it will keep on looping till 4. Okay, and this is how you have set up like 5 pins of the Arduino as an output device. Getting my point? So you got to know now, like writing pin mode 5 times and writing just 3 lines of code to repeat it multiple times and make everything five like output. It's more easier, right? You got, till here you got it. How to use for loop and how can you reduce the line of code here? Let me know. Did you got till here like and the coding part? Earlier you were writing 5 times the pin mode. Now it is like only one time you are calling just by the index value you are referring it. Right. By which what happens like in order to write multiple times the code. Right? Yeah. Okay. So should we move ahead? Okay. Now we'll go to loop part. In loop part also just now we saw a code. You guys turn on the LED, again turn off, again turning on the LED 2, turning off LED 3, turning on, turning LED 3, turning off. In this way you wrote such a big line of code. Oh my god. It's a really like a hard job to write that much line of code multiple times and copy pasting things. So again we can reduce there also. How? Again, it's the same logic. I is 0, then I is 0 and is like lesser than 5. True. Then LED number, LED I. What is I value now? 0. Turn it on for few seconds, like half a millisecond. Like 500 millisecond means what? Half second, right? So half second, then turn it off. Then after it comes to this line, line number 18, the moment it comes to line number 18, what it is doing? It is going to this for loop. Now I value will become 1, right? Is it true? 1 is smaller than 5. It's true. Then it will be like LED 1 high. Now like what was LED 1? LED 1 was pin number 3, right? Pin number 3 will be high for half a second, then pin number 3 will be off for half a second. Then again it will go to the for loop. It will be now the 1 will become 2. 2 will on for half a second, then 2 will off for half a second. In this way that it will go. Now if I see the rhythm of this one, you can see, okay, the pins which I have selected here are not the same. Let me put it. Pin number 13, pin number 12, pin number 11, pin number 10, and pin number 9. Okay, if I start a simulation again, okay, so you can see it's the same code which we wrote earlier. If you remember the old code, like I will show you the old code. This was the old code, right? You have repeated the LED to blink on and off for 5 times. Same code you have repeated 5 times, right? Now it has been reduced for how many lines? 21 lines. Like, yeah. If I remove all these comments, all those things, it will come less than 18 lines also. 18 to 16 lines, it will reduce more. So you can see the drastic change using just one for loop. You have achieved the same thing only. Just your line of code has been reduced now. So till here, did you understand everything? How to blink this LED pattern? Then we will start with a new topic today, which is yesterday's classes. In yesterday's class we learned about output devices, right? Today we will be seeing how to take input from the sensors. Okay, got it? Let me know that if you have understood. Give me a thumbs up. Did you understand it? Now, before starting the new topic, I will be again clarifying basics of the things which you have learned yesterday and what else we will be learn, like how it will be beneficial in today's class. Okay, you also take out your books and we will start doing it simultaneously. Now, what all applications we can make out of this? Example, yeah, that day, few people told like the moment I enter the room, the light should turn on. The sensor will give what? 1 or 0, right? We'll try to find out whenever it is 1, my LED should, like my room light should turn on. The same way, if I want to, another like if anti-thief thing, right? If somebody steals my bag, sensor will give output, right? So it should read, the Arduino should able to read that and then take an action. So whenever you need to make some applications where you need to take that input and then start give an action to it, that time we will be using input functions, right? So example, in yesterday's class, we learned how to make a circuit to connect the Arduino with an LED using a resistor. Now, if in today's class, we will be taking an example of switch button. Now, what is the symbol of switch in your, like you have studied in your 10th and 11th, 12th, right? What is the symbol of switch? This is a symbol of switch, right? Correct? Now, in this switch, now what I will be doing, I will check that is the switch is on or off. Based on that, I will trigger an LED. Okay. Now, this is my Arduino. Okay. Let me know, is it visible or not? Is it visible whatever I am writing here? I hope it is visible. Yeah, okay. Now, if I want to connect it, example, yesterday we connected a pin in pin number 13, we connected a LED, right? We'll continue with that only. But in today's video, we will be connecting the switch in pin number 12. Now, if I connect it to the pin number 12, and I will switch is like how does a closed circuit work? You will be having one high voltage which will be connected to a switch, then again switch will be connected to a bulb, then bulb will connected to ground, right? That was a basic circuit which which we have done in our school days. The same thing here also. Switch. Now I will be connecting a 5 volt here. Okay. This is my power supply. Getting my point? This is my power supply from where I will get high voltage here. Here I am getting 5 volts. Okay. Here I am getting 5 volts to trigger this. Now what my Arduino should do? My Arduino should check that it is getting high or 1 or 0. What was the digital signal? Digital signal will be 1 or 0, right? What is it, how does the digital signal looks like? If it is a chart, digital signal will be like this, right? And where our top part will be 5 volts and 0, like 0 will be our low volt, like off state, right? On or off. Getting my point? Now, here also, now again we will connect a LED here with a resistor. I hope you remember from the yesterday's class what is the LED symbol. And again we will connect it to ground. Okay, right? This is the circuit basically which we will be doing, right? LED blinking, then we will be turning on and off this light. But here is a catch now. The thing is, now in environment, we learned yesterday, right? Analog signal and digital signals. You remember that from yesterday's class. Now, the one thing which you need to remember is there is external noise. Like there is too much of noise. Your hand might have electrostatic energy. You're the table where you have kept this project and doing this. That might have a noise, like some electrical noise will be there, which can trigger this Arduino. Which can like Arduino can easily mistook it as a high voltage or triggering voltage. Okay. Example for Arduino, if I talk, it is like around 2.6 volts or like around 2 volts. In 2 volts only this Arduino will get triggered. Like okay, it's on. Though it is not on, see, it's open, right? Though it is open, Arduino will think that it's on because of what? Environmental noise. So to reduce environmental noise, we have a concept of pull or pull down resistors. Okay. Now what is pull up and pull down resistors? We will be learning now. Pull up or pull down. Okay. Now I will be explaining with pull down, which will be really easy to for you to understand. And it's completely opposite also of pull up also. Pull down means in general English term. What does a pull down means? Pull down means you are pulling somebody down. Right. Now, as I told, Arduino can get triggered in 2 volts also. Right. Arduino can get triggered in 2 volts. Now, if I try to eliminate that 2 volts, like I will like, no bro, I'll pull it down. What will I do? I will connect this to ground. But again, here is a catch. Now, if I connect this to the ground, what will happen? It will be always zero, right? Whatever noises comes, always it will be absorbed by the ground. But the moment you turn on this switch, the moment the switch is connected, it will create a short circuit. Why? Because all the current flow, whatever was coming from here, it will go directly there. Right? It should not happen. It will damage the board. Remember that. It will damage the board. So now you will tell like just now you told sir we need to connect to it ground to reduce all the environmental noise, right? We can. What you need to do? Connect a resistor here by which it will act as a load, by which it will not short circuit the things. Okay. What you will do? Now now I have connected with a resistor here. and resistor is connected to ground, right? Resistor is connected to ground. Okay. Now what will happen whenever the switch is on? We have learned one basic things in our school days. Always electrons runs towards the low resistivity area, right? Now see, the moment you close this switch, what will happen? Whatever the current was there, instead of going it here, since there is a high resistance here, since there is a high resistance, it is electrons are not going this side. All the electrons will flow from positive to Arduino directly. Okay, but whenever the switch is on, like when the switch is in open state, what will happen? The small environmental noise which will be there, that will be absorbed and it will go to ground. Okay, this is known as pull pull down. This is pull down resistors. Now, pull down means you want to know that if you put it in ground, the default for Arduino will be 0. It is eliminating all the positive charges. That's why the voltage is 0. This is known as pull up resistor. Now we will be learning about pull down resistors. Okay. Same thing. Pull down is not, it's not a rocket science. Pull down is the same thing. Just in place of, right. Okay. Let me try and show you. Did you understood the pull up, pull down first? Let me know in the comment box. Did you understood the pull down a concept and why are we using this resistor and how the current flows from the switch and goes to environment Arduino, all those things? Did you understood? Let me know. Do you understand this thing? Like why do we use a switch here? As a we if we use direct switch, we can do it can trigger 1 or 0. But the thing will be like it can create an environmental noise. Because of that, to eliminate that, we're making it pull down. Okay. Now pull up means I will always pull you upside. Now what is up? Up is what is up? Up is 5 volts, right? As we told. So default will be 5 volt. Earlier in pull down, default was 0 because it is like you are trying to off it every time, right? Now, yeah, it's pull down. This is pull down. This diagram is for pull down where you have connected a switch in a 5 volt and you have connected the Arduino input pin with the ground using a resistor to prevent short circuit. Right? You are pulling it down, not to pull it up. But you need to connect 5 volts, right? In this area. So instead of connecting ground with a resistor, now I will connect here 5 volts. What I will connect? 5 volts I will connect here. 5 volts. And in the place of switch is also giving 5 volts, right? Now this both will clash. So I will make the switch as ground. It's completely reverse now. Now what is happening now? You see here. To prevent any kind of noises. Now 5 volt will keep on power supplying it. Now it's an open circuit, right? Since it's an open circuit, electrons can't go from like from 5 volt to resistor to this side. It can't go. Why? Because the switch is open. It will go to Arduino. It will go to Arduino, right? So Arduino triggering voltage was 2 volts. Now because of this circuit, what will happen? It will get triggered. Arduino will be like always high or Arduino will be on always. But as I told, it will always find the easiest path to go. The moment you turn off this switch, the moment you make it off circuit, what will happen? As I told, electrons always go with the shortest distance and the less resistivity. Arduino also has its own inbuilt resistivity, right? Whatever 5 volts are coming from here, instead of going into Arduino, what is happening? All the charges are going towards ground. And whatever charges was accumulated here in Arduino side, that also will get drained because all the charges which was here, which was coming from the 5 volt, it will all go and drain it in ground. So then what will the state of Arduino? It will be 0. Right? Yeah. This whatever you have learned on pull down resistor. Pull down resistor was you used to connect the Arduino pin with ground to make it default 0. Now, if I want to make it default 1, like I want 1, it should be always triggered, it should sleep for a few seconds. That time that I will be using pull up register. This part you understood? Let me know. This theoretical part did you understood? Then we will go and start making in the simulation part. Let me know, did you understood this thing or do I need to repeat it anywhere from again? Give me a thumbs up if you have understood this part. Any doubts here? Like why are we using pull up or why are we using pull down? You understood this part? Great. Now should we start with the coding part? Okay. We'll start with the coding part now. Okay. Now let's start with the coding part. So open up your Tinkercad. Yesterday's project only whatever we have opened. Open your Tinkercad. I hope you have opened your Tinkercad. Is it ready? Let me know if it is ready. Yeah, it's ready. Great. Now we'll be making a circuit. Okay. Now let me delete all this LED first. Hmm. Okay. Now we will start from scratch. Now you have taken an Arduino board. Now as we learned about in this part, we will taking with like pin number 13 as a default for LED. Okay. I will connect the LED. I will put the LED here. Then I will go with the resistor. Okay. Let's change the LED color today. We will put it something like green. Okay. Now I will connect the cathode to the ground as we know. Okay. Then I'll make it as a black color. Okay. Wait. And then I will connect pin number 13 to positive of the LED. This is the basic part, right? Now we will connect an LED. Now if you go to the right side corner, you will be saying push button. Type push button, PSH push button, BUTTON, push button. You got the push button. Drag it and keep bring it here. Okay. Now you can say terminal A, terminal 2. Both are A here. Terminal 1 B, terminal B, like this, right? So now let's connect it. Generally, this AB will be towards one side and 2 and this thing will be in other side. Okay, let's connect it. Um, okay, I'll connect it here and I will connect as I told. Should we make it pull up or pull down? Okay, we'll go with pull down. What in pull down? What we have learned? What we should do in pull down? In pull down, we should connect a resistor, right? So I will connect a resistor now. We all normally get pre-built circuit also. Yeah, we do get. Okay. So pull down means I will connect this part to the ground. So what is happening here? Like it is in default, it will be always low. Okay, wait. We should connect it here since the terminal is here, right? So yeah, that's it. Okay. So now what can you see? The pin number 12, which is going to pin, like which is going to button, right? It is connecting to the ground, by which it is not creating a short circuit because there will be load in between. And whenever any noise comes in pin number 12, if like example you are touching the on the table where you have kept, there might be some little bit of here and there noises will be there, which is all eliminated by using this resistor. Now what I will do, I will just connect it, I will just connect this side, like this part of the terminal. Okay, wait. Yeah, okay, I'm correct. The pin number B, like the pin number B is another side, right? I'll connect it to the 5 volts. Now, where is 5 volt? If you go to the Arduino bottom, you can see there's a 5 volt here. I'll go and I'll connect to 5, Arduino 5 volt. Let me know you have reached till here or not. It is great. Now, let me explain the entire thing using by this example of circuit. Now, see, 5 volt is coming here to the button. Now button output pin is going to 12. Now what I told, there might be a noise. So to reduce the noise, you are connecting in the output where the 12 is going. You are connecting a resistor and putting in the ground. By which what is happening? You are reducing all the noises here. Okay. In this way, this part has been done. Now we'll go into the coding part and we'll start writing the code. Okay. Now, okay. We have one LED and we have one button. So I will write in LED. Okay, is my screen is visible? Yeah. In LED, we have one LED in pin number 13, right? And we have one button. In button is in pin number 12, right? We have defined two variables. Now we will set up. Okay. Pin mode and not pin mode. Void setup. Okay. In void setup, we will be setting up these two pins. Now, LED is the input or output device. LED is the output device, right? So we will be writing pin mode, M capital MOD, pin mode, LED is output device, OUT, PUT, output device. Okay. Then button is the input device or output device? It's an input device. So I left pin mode, MOD mode, pin mode, button, BUTTON, button is input device. Okay. Got to know? Now pin mode, you are telling the Arduino that pin number 13 is for output and pin number 12 is for input. So Arduino will expect 1 or 0 from all. It will always expect it from where? It will expect it from input device, right? Like okay, Arduino knows that okay, I'm going to get some data here. Now void loop. Loop means what? Yesterday we learned loop means which will keep on looping multiple times. Okay, which will keep on repeating multiple times. Now inside this. Yesterday we learned digital write. You remember guys? Digital write to turn on and or turn off the LED. Now I want to read. What is the signal? What is this signal? It's on off signal, right? It's a digital signal. So what will we read? Digital read. Yesterday's was digital write. Today we will be learning about digital read, which will give a value to us. Okay. So I will write a if condition if digital read. DIGITL digital read. Again W capital camel casing known as right, WRIT, right, digital, right. Sorry, not right, read. READ, read. Now, what pin I should read? Pin button, right? BUTTN button. Okay. What I am saying, whenever this pin number button is high, high means what? One, right? Whenever it is equal to one. I'm just comparing. It is a comparator, right? Digital read will give me answer in 1 or 0, right? So I am telling that whenever you are reading it as a 1, what you should do? You should turn on the LED. Now you have read it. Now how will you write it? DIGITL digital, WRT digital, right? Which pin to write? LED, right? LED 1. Okay, it means I am turning on the LED and I am closing the bracket and I will like else If this is not happening, what to do? Digital right LED to get off. Okay, this much you have understood. Let me know if you have understood till now. See, I will explain it again. LED is in pin number 13, button is in pin number 12. In void setup, we told Arduino what to do with the pins. We told Arduino that you use pin number 13 to give output. You take pin number 12 to take input from it. Now we have learned yesterday digital write, by which you are writing digital signals. What is digital signal? 1 or 0, right? That thing you have learned. Now if you want to read, what it will read? It will read 1 or 0, right? So you have digital read, or which button you are reading. You are reading button 12. That's why you have written button here. Instead of that, you can write 12 also. And 1 or 0, right? So I have told whenever it is equal to 1, it means whenever it is 1, you should turn on the LED, or else you should turn off the LED. Understood the coding part? Let me know. Did you understand the coding part? Let me know, guys. Okay. Okay. There's a lag. Okay. So since you have understood the LED part, now let me start simulating it. Okay. Now I will start the simulation. You can see. Okay, LED is on now. Why? Why it is on? It's a very good question. Okay, did we connect it to the wrong pin or something? No. Okay, let me start the signal again. Okay, got it. Now, if you have rotated your button, check once that is it terminal one. It is showing terminal one A, terminal two A. Okay, check once. Check that it is showing terminal one A and two. So you connect it to the same side only. Don't connect it to the different side. I don't know when it got rotated here. So what is happening here? This is a normal switch, right? It is open state right now. It is in open state. Now the moment I click on the button, it will trigger the switch. Now I will start the simulation here. Now see, whenever I am pressing the button, see the LED is on. I am leaving the button, it's off. Again, if I press the button, on, off. Hover your mouse towards your button and just press it on or off. You will get to know the LED is oning and offing. Now you will be saying that there might be a short circuit also, right? Okay, so what we will do, we will try to change the code now. Now, whenever I am pressing the button, the LED should turn off. So I will just make it 1 and I will make the top part 0. So what is happening? Whenever the button is reading as 1, it should turn off the LED, or else it should turn on the LED. Okay. Now let's start the simulation. See, you can see it here. The LED is on. I have not done anything. LED is on right now. Now I will press the button here. The moment I press the button, you can see that LED is off. Okay. Again, if I leave, LED is on. Again, if I press, LED is off. Right? In this way, you have learned the pull up concept, a pull down concept, and you have learned how to take input from the users and how can we do this on and off things by playing this. Did you understand this part? Let me know. You understood this much part? Let me know. So I have given you today's homework also. What you need to do, connect five buttons and five LEDs, and on the each button press, the LED will turn on by itself, and you can turn on and off the pattern also. Example, if you are pressing the LED number one, it should go in some pattern. If you are pressing LED number button number two, it should go in other pattern. Then you can change the pattern or stop the pattern, whatever you want. You can come up with your creative minds, and we can make it. Till here you have understood? Let me know. Yeah. Okay. So can you do the homework today properly? Okay, how to connect the switch? Okay, see. Again, we'll repeat this entire task once again. Okay. Now I will delete everything. You can also delete. Whenever you are doing it in real life scenario, it will be more easier compared to this online simulations, because we don't used to get like what is the direction of the switch, all those things. Okay. Now again, take an LED. LED. So okay. For fun, I will be taking. Should I take RGB LED or should I take a normal LED only? Okay, RGB LED will be your homework. Okay, connected. I have connected RGB, connected to the ground. To ground, ground should be black in color. We'll try to make it neat and clean now. Okay, now we can pin number 13 to pin number 13. Okay, no, we forgot. We should have a register also, or else we'll burn it out. Take a register here and get to pin number 13. 13. I'll make it as a red color. Okay. Now I will take a button. Now here you have push button, slider button, any kind of button. Go with push button only, it's fine. You have push button here. Check the when you hover over the terminals, the four legs which you can see. If you hover, it should have terminal 1A, terminal 1 as a terminal 2A. Like it's like on and off for the A side and on and off for B side, like that it is. Okay. Basically the switch is like if you see this kind of push button diagram, I will let me show you the push button diagram. How does it look like? I guess because of the push button diagram only you are getting confused. This is the push button, right? Now what is happening in this push button is this wire is connected from inside. From inside it is connected. From inside it is connected. Now there is a pad here. Whenever we press on this pad, it touches the two terminal. Example, if I show you a side view of it. Example, this is a side view of this button. Now there is a pad here. Okay. This is the stick which you see generally. Right. This is a stick which you see. Now, whenever you press on this button, like whenever you press on this button, what happens? The contact pad will touch these two parts. Okay, it will touch this two part and it will connect the switch. Okay, that's why, like, that's how the push button works. So, it is like 1A, 2A. It will be 1B, 2B. Like this, it is showing in a Tinkercad, right? Make sure of that. Now, I will connect this 1A to pin number 12. Okay. Okay. I've entered pin number 12. Now, as I told, there will be a high chance there will be a noise, right? So what I will do, I will make it as a ground. So what I will do for ground, what we should need we need a resistor. We'll take a resistor and we'll connect it here. Okay. Now we will connect the other end to the ground. Got it? Now by this, what is happening? You are just removing whatever current is flowing in this pin number 12. You are eliminating using this resistor. You are making it pull down. You are not letting it to be high. Now to make it high, what you will do? You will connect the terminal 2A to the 5 volt. Where is 5 volt? 5 volt is in the bottom part of the Arduino. If you take it out from outer side, it's fine. Okay. You can see this circuit diagram. Can you see this circuit diagram? What I am doing? You have connected from pin number 5, like 5 volt, you have connected to switch one side, and another side is going to 12. Now what will happen whenever you are pressing this button? Entire 5 volt will go to pin number 12. But as I told, there will might be a noise. So again, there is a resistor to make it pull down, by which what will happen? If any external noise comes, like if you touch any electrostatic charges are there, it will not trigger the pin number 12. Okay. Now again, if you see the coding part here, we have learned, like as you can see in the button is connected to pin number 12 and LED is connected to pin number 13, right? Then LED is for output, button is for input. What is the signals with which we are playing right now? We are playing with digital signals, right? In digital signals, we will be doing it on or we will be doing it off, right? On or off. So what will happen whenever you are pressing this? It is a reading one or on or off, which is one or zero. So we are at digital read. After digital read, it is reading whatever value will be there. If it is one, it will be like is equal to one. If it is true, it should do something. In this code, it is like whenever the button is on, like whenever it is sending signal one, the LED should turn off, or else the LED should turn on. If I start the simulation, if you see LED is on. The moment I press on the button, LED is off. Again, if I leave this button, again it is like on, off. Right? You can play around with it. Example, yesterday we learned about LED blinking code, right? So you can do one thing. Whenever the button is clicked, the LED blinking should start, or else the LED should not blink. Okay, what we should do for that? Here, same code, pin number LED, like when LED is on, right? Then again we'll put a delay. We'll put a delay of half a second, 500. As we know, 1,000 milliseconds is equal to 1 second. So delay for half a second. Then again, digital write. Where digital write, where we will LED should be off for half a second delay, right? Now I will keep it whenever I press this button, the pattern should turn off. It should not turn on. Now if I start this simulation again, if I start a simulation again, you see nothing is nothing is happening. Why? Because the signal is zero right now. This like digital read is reading signal zero, which is not true. So what is happening? Digital write is zero. But the moment I press the button, you can see LED is blinking here. It's not like I'm closing or offing the button. It's not like that. It's LED is blinking. Okay. The moment I leave the button, you see the pattern has been stopped now. Now we will make it reverse now. We'll make it not equal to. Okay. Us what we'll do, we will click on whenever we want, we will like whenever we are not pressing the button, the LED should turn it should be always on, and whenever we are pressing the button, it should go like it should keep on blinking. See, I have not pressed anything, LED is on, but the moment I press the button, see, it is blinking. Getting my point? So do you remember something out of this? where can you see this kind of things? Whenever you press button, it will blink. Can you recall like where in day to every day we see this thing? Can you just recall where do we see this thing every day? Bike indicators, you remember? Like car indicators. You are driving properly. The moment you turn on the switch, that when you slip it towards your left or right, it will blink that side LED, right? Getting my point? Whenever you are pressing the button, what is happening? Whenever you are pressing the button, what will happen? Okay. Yeah, it is blinking. The same thing is here also. Whenever you press the button, it will start blinking. So I will recommend you one thing today. Make a simple project which will be blinking to make a car indicator. Okay, left and right. Take two switch, take two LEDs, and blink the LED based on which side button you are clicking. Okay, there is another button. There is a slider button here. You can use this kind of button also, where the center will be always common. It is written here also common, and another will be terminal 2 and terminal 1, like this. So connect, like if I show, I will just delete this part, replace it with this one, where I am connecting this terminal 1 with the register. Okay, and I will be connecting this part also to the register. Okay, this is known as a slider switch. If you are not getting in the Tinkercad, you will search slider switch here, you will get it. Okay, and the common should be what? Common should be positive, right? So I connect it to the positive side. I'll take it to positive side and I'll connect it. Okay. Now another side I will be connecting to the other side of the part. Terminal again. I will connect it to, assume I will be connecting it to pin number 11. Okay. I have connected to pin number 11. Now again it will also have a noise, right? So what we will do, we will connect a resistor here also. By which what will happen? If any default noise is here in pin number 11, it will be eliminated. Okay. What will be? It will be eliminated. So don't get confused by this switch. You can easily identify. See, the common is connected to the 5 volt. And there's one input pin which is connected to pin number 12. There is another input pin which is connected to pin number 11. But both the input pins are grounded. Why? Because if there is any noise, it will reduce. It will eliminate by itself. Okay. Now I will connect one more LED to make it like a small indicator kind of thing. Right. I will not make the full thing. You should make and show me the project. This is the homework. Make a car indicator and stop light. Okay. This is the two homeworks which I am giving for today's class. Okay. I will take the LED again. I will take this LED as some other color. Um, I'll make it green color. Okay. I'll connect the cathode to cathode. I hope you are doing with me only. I have connected cathode to cathode and I will connect pin number. Okay, I will connect a register here now. And this register will go and sit into pin number 10. Okay, I'll share this with you. If you want, you can copy it. Okay, don't worry. I'll share this file with you. Okay, now this is the basic code. Now we have two LEDs, two input and two outputs, right? Now let's start the coding part. What you have one LED. So I will write red LED. Red LED is pin number 13, and I have another green LED. Green LED is connected to pin number what? Pin number 10, right? I have one input. It's like left input, right? Left input line I will write it's in 12, and in right input RIN is equal to is connected in pin number what? Pin number 11, right? Done with this thing. Then again I will call this all LEDs like again red LED and lin. I'll just copy it and I'll just again do it. Red, green, green LED is for output and red LED is right is for input. Now what I can do, I can just write like digital read. What I will do, whenever digital read is reading left in LIN, whenever it's reading the left side pin, which is the left side pin, pin number 12, right? Whenever it's reading high, what it should do? It should blink which one? Pin number 13, which is red color, red LED. It should blink red LED. Okay, it should blink red LED. But whenever it is on the other side, it should blink which color? Green LED, right? It should blink green LED. Green LED. Okay, getting my point. Now we will start the simulation again. Let's start the simulation. Okay, there's a red right IN. There's a error in this part. Okay, let's see what's the error. Okay, I have written red in. Okay, we start the simulation. Now you can see the red LED is blinking. Right, you can see the red LED is blinking. But the moment I click on the switch, okay, wait. If I'm clicking on the switch, the pin number 12 is getting high and it's running. Okay, okay. Both are in the same ground. That's the issue. One of the issue. Okay, we should fix it. So what we should do? Nothing. We should make the ground separate. Okay. We'll make a one more. We'll take one more register here and we'll connect it to the ground. Like what is happening right now is like it is taking the ground of the same pin and it is commoning it. Right. So now we have separated it. Now we assume that the error should not happen. LED red LED is blinking. The moment you click on the right side, green LED is blinking. Got it? See, left LED, left side this slider is red color is blinking. If I click on right side is blinking. Do you like the project? If you like the project, do let me know. Put thumbs up. Almost like all we have only 1 minute to end. Do you understood the entire concept today? So I have given you two homeworks today. Blink four LEDs with different patterns with five buttons and make car indicators and all those things. Like whenever you press one button, the red light should grow, which will represent as stop. When you press switch, it will make turn on the headlight. And if you want to switch left and right, you can make it as a left indicator, right indicator. And if you press the button, it should open a hazard light. This is the basic things by which you can understand the basic car, bikes, how they work. Right? This is their homework, and who can come up with more features in their project. I will be marking them again like yesterday's class. Yesterday also I have noted many roll numbers and their names and I have reported to Ramesh sir. Again in today's class also I will be seeing who come up with the best creativity ideas and I will mention their name also to Ramesh sir. Okay, so I hope today's class you have enjoyed everything. Did you enjoy today's class? Let me know. Did you understood all the concept why we use registers to pull down or pull up? What can go wrong? How to prevent it? And how to read from the input device like switch or any other sensors. Did you understand everything? Do let me know. Yes. Okay. Okay, great. So do I need to repeat everything again from beginning once again? Should I start summarizing it? Are you yes? Okay, I will summarize it once again. Okay. So in today's class we learned about digital read. In yesterday's class, we learned about digital write, which is writing is 1 or 0. If you're reading also, you will read only 1 or 0, nothing else. Right? So we learned about digital read, how to implement it, and how can we play around with it. Where you can use multiple senses, come up with your own creativity, what all you want to do, and you can start doing it. We learned about this new function today. Then we learned about a list, like also known as array, where you can reduce the n number of lines using just for loop, where we learned how does a for loop works. Then we learned basic of theory, like how a pull up or pull down register works. Okay, got it? Yeah, it's based on pull down. Yeah, you're correct. Why it is based on pull down? You can see if you see the circuit here. If you see the circuit here, the resistors are connected to ground. Right? You can see that both the resistors, like if you see both the resistors are connected to where? It is connected to ground. And only the high voltage is here. Now the same place, if I would have done this high voltage into ground and this LEDs into high voltage, then it would be pull up. Okay, the same thing, just ulta it is now. Now you're connecting the resistor towards the high side, where the Arduino default will be always 1. Here default is what? 0. Because whatever current is accumulating here, like in the pin number 12 and pin number 11, it's already drained by ground. Right. Now, if something comes, like if signal comes, as we know that electron always pass to the shortest distance, since here we have a resistivity, it will go directly to the pin, by which the Arduino will get triggered. Right. This is a pull down. Pull up is different. Again, what will happen? You're always giving a high voltage to Arduino, to the resistor. But the moment you short circuit the switch, when you press the switch, what is happening? Whatever current was there, since Arduino also has some resistivity, right? So the electrons will stop moving there and will go to ground, by which it will short circuit it. This pull up. Okay, so that's how the difference between pull up and pull down. I hope you understood it properly, and you can take this as if you want. I will draw it. You can note it down. Okay, I will draw it here, note it down, and by this we will end this session, today's session. Okay, now how will you make a pull up resistor? You have 5 volt, right? You have 5 volt. It is connected to resistor, and it is connected to switch. Okay, and then it is going to ground, right? And your MPU will be connected here. What is MPU? Microcontroller microcontroller unit, MCU. Okay, this is how the circuit of pull. What is this? Pull up or pull down? Let me know, guys. Comment me. What is the circuit? Pull up or pull down? So what I have done, I have connected the MPU signal with a resistor to the 5 volt, and the switch is in the ground side. So tell me, it is a pull up, pull down concept. What will be the default signal which the Arduino will be getting? 1 or 0? What is the default signal which Arduino will get? It's a pull up resisting circuit, right? Yeah, Nibia, yeah, Nabia, sorry, Nabia, yeah, correct, Nabia. It's pull up, correct? Because why? Because whatever electrons will be coming here, right? Whatever electrons will be coming here will be going like all the 5 volts will go from here to MPU, right? It is going all to MPU. But what will happen? The moment you press this button, all the electrons instead of going to RT like MPU, it will go straight to the ground. Right? This is the pull up concept. Now pull down concept. The same thing again. In this place we will have 5 volts, but now we have switch here. Okay, we have switch here and it will go to ground. Okay, my diagram is very bad. Okay, and it will go to ground. And again here will be one MPU which is going to be MPU now. Okay, now you can see whatever the like electrons will be coming in this area will be grounded, right? It will ground. So that's why default will be always 0 here. Here default will be 0, here default will be what? 1. But the moment you press the button, since the electron always has the shortest distance, it will go from 5 volt to the Arduino only. It will not go to ground. Right? Got it? Pull up and pull down. You understood everything? How does it pull up and pull down works? So let me recap once again what all we have learned today. We have learned about what is pull up, what is pull down, what are the common mistake what people do with in pull up and pull down, and we learned about how to optimize the code properly, and then we learned about what we learned about how to take input from the sensors. In today's class, we have not taken sensors; we have taken like a button. In tomorrow's class, we will be taking sensors, multiple sensors, and we will try to do it. And then by which we will be trying to what? Help me. Based on that, we will trying to do some actions like we will turn on the light or turn off the bulb, like that. All these multiple experiments we will be trying out. Okay. So I hope you love today's session. Let me know. I hope you learned today's session. Okay. Thanks a lot. Like yeah, today we were having a little bit of less audience, but yeah, valuable audience. Like I hope you learned today and you came up with multiple ideas also. Like oh, we can make like this, and you learned how your car indicators works. All those things, right? So these are things you learned today, right? Okay. Thank you. Have a great day and keep like be engaged with all these kind of small projects and whatever projects you might have understood. Mm, okay, what is the use of pull up and pull down? See, as I told at the beginning of the lecture, right? The pull up and pull down is basically to reduce the noise, environmental noise, because we are surrounded with noise. Sometimes what happened, the Arduino will take like some noises from the environment to reduce it. What happens? Ki if you use pull up or pull down, you are eliminating all the noise by which Arduino takes only the input which we want to make him listen. Right? That's how we use pull up and pull down to reduce all the noises. Okay. Thanks a lot. Have a great day and thank you, Ramesh sir. And I hope all of you enjoyed today's class. Okay, bye bye. Done, bro.